Imagine a world where your phone predicts your needs before you ask. Robots perform life-saving surgeries, and AI creates art that moves you to tears. But here's the real question: will this technology control us, or will we control it? Dive into AI for everyone. A simple guide to understanding and using artificial intelligence. The eye-opening journey that reveals how artificial intelligence is reshaping your life, from the apps you love to the future of your job, and equips you to thrive in the age of smart machines. Perfect for curious minds aged 10 to 100. This isn't just a book about AI. It's your survival guide for the next decade. Press play, the future won't wait. Chapter 1. What is AI? Meet your future helper. Artificial intelligence, or AI, is like giving machines a brain, but not the kind made of flesh and blood like ours. Instead, it's built from complex code, data, and algorithms that allow computers to learn, solve problems, and even make decisions. You might picture robots from sci-fi movies, but AI is far more subtle and already woven into our daily lives in ways you might not even notice. Think about the last time you asked Siri or Alexa a question. That voice answering you isn't a real person. It's AI trained to understand speech, process information, and respond in a way that feels almost human. Or consider Netflix, which somehow always knows what show you'll want to watch next. That's not magic, it's AI analyzing your past choices and predicting what you might like. AI is everywhere, even in places you wouldn't expect. When you unlock your phone with your face, AI is comparing your features to stored data. When you type a message and autocorrect fixes your mistakes, AI is guessing what you meant to say. Even traffic lights in some cities now use AI to monitor traffic flow and adjust timing to reduce jams. But how does AI actually work? Unlike humans, who learn through experiences, emotions, and reasoning, AI learns by processing massive amounts of data. It looks for patterns, makes connections, and improves over time, but it doesn't truly understand things the way we do. For example, an AI can recognize a cat in a photo because it has analyzed thousands of cat pictures, not because it knows what a cat is. Let's take a real-life story to make this clearer. Meet Zoe, a 12-year-old who loves ordering pizza through an app. The first time she used it, she typed, "I want a cheesy pizza with no mushrooms." The next time she opened the app, it suggested, "Try our extra cheesy margarita." How did it know? AI had studied her order history, spotted her preference for cheese, and made a smart guess. AI isn't just about convenience. It's also helping solve big problems. Doctors use AI to analyze medical scans and detect diseases earlier than ever before. Farmers use AI-powered drones to monitor crops and predict the best time to harvest. Even artists and musicians are experimenting with AI tools that can generate paintings or compose music. But AI isn't perfect. Sometimes it makes mistakes, like when a voice assistant mishears a command or a recommendation system suggests something totally off base. That's because AI is only as good as the data it's trained on. If the data is biased or incomplete, the AI's decisions will be too. You might wonder, could AI ever think or feel like a human? The short answer is no. AI doesn't have consciousness, emotions, or desires. It's a tool, not a mind. It can mimic creativity like writing a poem or designing a logo, but it doesn't enjoy doing it. It's following patterns, not expressing itself. So why does AI matter to you? Because it's shaping the future in ways both big and small. The jobs of tomorrow will rely on AI, from healthcare to entertainment to transportation. Understanding how it works now will help you navigate a world where AI is as common as electricity. The best part? You're already using AI every day, even if you didn't realize it. Every time you search the web, get a targeted ad, or use a filter on a photo, AI is working behind the scenes. And the more you interact with it, the smarter it gets. But AI isn't just something that happens to you. You can also learn to use it yourself. In the coming chapters, we'll explore how AI learns, Chapter 2, where it's already making a difference, Chapter 3, and even how you can train your own simple AI, Chapter 9. Some people fear AI, imagining robots taking over the world. But the truth is far less dramatic and far more exciting. AI is a helper, not a replacement for human ingenuity. It's a tool that can amplify our abilities, solve tough challenges, and create new opportunities. The key is to approach AI with curiosity and a critical eye. How does it work? Where is it useful? What are its limits? By asking these questions, you'll be better prepared for a future where AI is everywhere. So the next time your phone suggests a faster route home, or your favorite app seems to know what you want, take a moment to appreciate the invisible intelligence at work. You're not just using technology, you're interacting with one of the most powerful tools humans have ever created. And this is just the beginning. AI is evolving fast, and in the next decade, it will become even more integrated into our lives. Whether you're 10 or 40, understanding AI now means you'll be ready for whatever comes next. Chapter 2. How Machines Learn. Teaching computers like a teacher. Imagine you're teaching a toddler to identify different fruits. You show them an apple and say apple, then a banana and say banana. At first, they might call everything round apple, but with enough examples, they start recognizing patterns. The banana's shape, the apple's stem. This is exactly how we teach artificial intelligence through machine learning, except instead of a human brain, we're training computer algorithms with massive amounts of data. The magic of machine learning lies in its ability to improve automatically through experience. Unlike traditional programming where humans write every rule, if this, then that, we feed the computer examples and let it figure out the patterns itself. It's like giving a student practice tests instead of just a textbook. The more problems they solve, the better they get at recognizing the underlying concepts. This approach allows AI systems to tackle incredibly complex tasks that would be impossible to program manually. There are 3 primary ways machines learn, each with its own strengths. Supervised learning is like teaching with flashcards. We provide labeled examples, pictures marked cat or dog, and the algorithm learns to map inputs to correct outputs. Unsupervised learning is more like giving a child a box of mixed toys and letting them sort them however they see patterns. Reinforcement learning resembles training a pet with treats. The AI tries different actions and learns which ones yield the best rewards in a given situation. Consider the story of AlphaGo, the AI that mastered the ancient board game Go. Developers didn't program it with strategies. They let it analyze thousands of human games, then play against itself millions of times. Like a chess prodigy studying past matches, it discovered winning patterns humans had never imagined. This same principle applies to more everyday AI. When Netflix recommends shows or your email filters spam, it's using similar pattern recognition from your past behavior. The quality of an AI's education depends entirely on its training data. Feed it diverse, accurate examples and it learns well, but give it limited or biased data, and it develops blind spots. A facial recognition system trained mostly on light-skinned faces will struggle with darker complexions. A chatbot exposed to toxic online conversations might pick up bad habits. This is why responsible AI development requires careful attention to the data we use to teach our machines. You've probably experienced machine learning in action without realizing it. When you type a search query and Google anticipates what you're looking for after just a few letters, that's the result of analyzing billions of previous searches. When your phone's camera automatically detects faces and adjusts focus, that's computer vision algorithms at work. Even the fraud detection systems at your bank use machine learning to spot suspicious transactions by comparing them to known patterns of fraud. Here's a fascinating real-world example. Farmers are now using machine learning to monitor crops. Drones take aerial photos of fields, and AI analyzes them to detect early signs of disease, nutrient deficiencies, or pest damage, sometimes spotting problems days before human eyes could notice. The system learned this skill by processing thousands of images of healthy and distressed plants, much like an agricultural expert gains experience over years of field work. To better understand how machine learning works, try this simple exercise at home. Collect photos of 2 distinct categories, like dogs and cats or cars and motorcycles. Shuffle them and ask a family member to sort them into 2 piles. First, give them 5 clear examples of each category. Then test them with new images. How accurate are they? 5. Notice how their accuracy improves with more examples. This mirrors the basic process of training an AI model, just on a much smaller scale. The key takeaway is that both humans and machines learn through exposure to examples and feedback. As machine learning advances, we're seeing remarkable applications across industries. In healthcare, AI systems can now analyze medical scans with accuracy rivaling expert radiologists. In conservation, researchers use machine learning to identify individual animals by their unique coat patterns or calls. Even creative fields are being transformed. AI can now compose music in specific styles or generate original artwork based on learned artistic principles. However, it's crucial to remember that machine learning has limitations. These systems excel at pattern recognition within their training domain but lack true understanding. An AI trained to diagnose lung cancer from X-rays can't suddenly start analyzing poetry. It only knows what it's been taught. They also can't explain their reasoning as clearly as humans can, which is why developing explainable AI is such an important area of research. The future of machine learning holds incredible promise. We're moving towards systems that can learn from fewer examples like humans do, transfer knowledge between different tasks, and even explain their decision-making processes. These advances will make AI tools more accessible and trustworthy for everyone. Understanding how machines learn gives us the power to use AI effectively, to recognize its limitations, and to make informed decisions about its role in our lives. As we'll explore in Chapter 3, this technology is already woven into the fabric of our daily routines in ways both obvious and subtle. The journey of artificial intelligence is just beginning, and its potential to augment human capabilities is boundless. But like any powerful tool, its impact depends on how we choose to develop and deploy it. With great learning comes great responsibility for both the machines and their human teachers. Chapter 3, AI all around us. The invisible helper in your daily life. You wake up to your smart alarm, which learned your sleep patterns and gently rouses you at the optimal time. As you rub your eyes, you ask your voice assistant about the weather. It understands your groggy morning voice perfectly. While brushing your teeth, your phone shows a notification about delayed traffic on your usual route to school. This isn't magic. It's artificial intelligence working quietly behind the scenes of your everyday routine. Most people picture AI as humanoid robots or supercomputers, but the truth is far more ordinary and fascinating. AI has become the invisible thread woven through our daily experiences, so seamlessly integrated that we often don't even notice it's there. From the moment we wake up until we go to bed, we interact with dozens of AI systems without giving it a second thought. These digital helpers have learned our habits, preferences, and needs to make life a little smoother. Let's follow 14-year-old Maya through her day to spot all the hidden AI. Her morning starts with a breakfast recommendation from her family's smart fridge, which knows what groceries they have and suggests recipes. On the bus, her music app plays a perfectly curated playlist that seems to magically match her mood. At school, her writing app checks her grammar and suggests better ways to phrase sentences. Even the school security system uses facial recognition to ensure only authorized people enter the building. Entertainment has been completely transformed by AI. When you watch videos online, the platform's recommendation engine isn't just guessing. It's using sophisticated algorithms that analyze your watch history, how long you view each video, what you skip, and even what time of day you typically watch certain content. Gaming AI creates opponents that adapt to your skill level, making challenges feel perfectly balanced. Streaming services use AI to automatically generate subtitles in multiple languages, opening up content to global audiences. The shopping experience has undergone an AI revolution too. Ever noticed how online stores seem to know exactly what you might want? Those customers also bought suggestions come from AI analyzing millions of purchase patterns. Virtual fitting rooms use augmented reality powered by AI to show how clothes might look on your body type. Some stores even employ AI cashier systems that automatically detect items in your cart, eliminating checkout lines. Transportation systems are getting smarter thanks to AI. Ride-sharing apps use it to match drivers with passengers efficiently. Traffic light systems in smart cities adjust their timing based on real-time traffic flow analysis. Airlines employ AI to optimize flight paths, saving fuel and reducing delays. Even the maps on your phone use AI to predict traffic jams before they form and suggest the fastest alternative routes. In our homes, AI has become the ultimate domestic helper. Smart thermostats learn our schedules and preferences to optimize temperature and save energy. Robot vacuums map our homes and clean more efficiently with each use. Security cameras can distinguish between family members, pets, and potential intruders. Even our appliances are getting smarter. Some washing machines now automatically detect fabric types and soil levels to choose the perfect wash cycle. Education has embraced AI in remarkable ways. Adaptive learning platforms adjust lesson difficulty based on student performance, providing extra help where needed. AI writing assistants help students organize their thoughts and improve their compositions. Language learning apps use speech recognition to provide instant pronunciation feedback. Some schools even employ AI systems that can detect when students are struggling emotionally by analyzing their behavior patterns and language use. Communication tools are supercharged with AI. Your messaging app likely suggests quick replies based on the conversation. Email services automatically sort your inbox and highlight important messages. Video call platforms use AI to enhance audio quality, reduce background noise, and even provide real-time captions. Social media platforms employ AI to filter inappropriate content while allowing genuine conversations to flourish. Health and wellness have benefited tremendously from AI integration. Fitness trackers analyze our movement patterns to provide personalized workout recommendations. Meditation apps adapt their programs based on our stress levels and progress. Nutrition apps can estimate calorie intake just from photos of our meals. Even our toothbrushes now come with AI that provides real-time feedback on brushing technique. As we've seen, AI isn't some distant future technology. It's here now, working quietly to make our lives easier, safer, and more efficient. The examples we've explored represent just the tip of the iceberg. In the next chapter, we'll dive deeper into how these AI systems actually think and make decisions, exploring the fascinating differences between human and artificial intelligence. Chapter 4. Brains versus computers, how humans and AI think differently. You're playing chess against both your best friend and a computer. Your friend smirks when they spot a clever move, while the computer instantly calculates every possibility without emotion. This simple scenario reveals a profound truth. Human and artificial intelligence operate in fundamentally different ways. Understanding these differences helps us appreciate what makes each special and how they can work together to achieve remarkable things. Human brains are the product of millions of years of evolution, capable of brilliant leaps of intuition and creativity. When you look at a sunset, you don't just see colors, you feel emotions, recall memories, and maybe even think about poetry. Our intelligence is messy, emotional, and deeply connected to our physical experiences in the world. We can learn from just a few examples, understand abstract concepts, and apply knowledge flexibly across different situations. AI systems, on the other hand, think through pure mathematics and pattern recognition. That chess computer doesn't understand strategy the way humans do. It evaluates millions of possible moves per second, calculating probabilities of success based on historical game data. While humans might develop general intuitions about good positions, the AI knows nothing of chess theory. It simply crunches numbers with incredible speed and accuracy. This difference leads to surprising strengths and weaknesses on both sides. The human brain is amazingly energy efficient, running on about 20 watts of power, roughly equivalent to a dim light bulb. Yet it can handle an enormous range of tasks, from solving complex math problems to interpreting subtle social cues in a conversation. In contrast, the AI that beat world champion Go player Lee Sedol required thousands of computer processors and massive amounts of electricity, all focused on just one specialized task. This shows how our biological brains remain unmatched in their versatility and efficiency. Memory works differently too. Humans have associative memory. Smelling fresh bread might suddenly remind you of your grandmother's kitchen from childhood. Our memories are connected through webs of meaning and emotion. AI systems have what we call parametric memory, where knowledge is stored as statistical relationships in their neural networks. They don't actually remember anything the way we do. They simply adjust numerical weights between artificial neurons based on their training data. One area where humans clearly outperform AI is common sense reasoning. A child knows that if you let go of a balloon, it will float away, no physics lessons required. But an AI needs to be explicitly trained on this concept through numerous examples. This common sense gap is why AI systems sometimes make ridiculous mistakes that no human would, like suggesting someone add gasoline to a recipe because the data showed many recipes include oil. However, AI excels where humans struggle processing vast amounts of data without fatigue or bias. While a doctor might review hundreds of X-rays in their career, an AI system can analyze millions in minutes, spotting subtle patterns invisible to the human eye. This complementary relationship, human judgment paired with AI's data crunching power, is transforming fields like medical diagnosis, scientific research, and financial forecasting. Emotional intelligence represents another key difference. Humans naturally understand sarcasm, read facial expressions, and navigate complex social situations. Current AI can mimic some emotional recognition by analyzing speech patterns or facial muscle movements, but it doesn't actually experience or understand emotions. This is why AI customer service bots sometimes frustrate us when they miss the emotional context of our complaints. Creativity shows an interesting middle ground. While humans have long claimed creativity as uniquely ours, AI systems can now compose original music, generate artwork, and write poetry. But there's a crucial difference. Human creativity springs from lived experience and emotional expression, while AI creativity emerges from recombining patterns in its training data. The most exciting developments happen when humans and AI collaborate creatively, like artists using AI tools to explore new styles or musicians composing with AI assistance. Learning speed presents another contrast. Humans can learn new concepts from just one or two examples. Show a child a giraffe once, and they'll recognize it forever. Most current AI systems require thousands or millions of examples to learn reliably. However, once trained, AI can instantly share its knowledge across countless copies worldwide, while each human must learn individually. Researchers are now working on few-shot learning to make AI more human-like in its ability to learn quickly. Perhaps the most important difference is consciousness. Humans experience the world subjectively. We have self-awareness, feelings, and a sense of identity. AI systems, no matter how sophisticated, are incredibly complex pattern recognition tools without inner experience. They don't have hopes, fears, or desires. This means that while AI can be tremendously useful, it doesn't want anything. All its actions ultimately serve goals set by its human creators. Understanding these differences helps us see where AI can best complement human abilities rather than replace them. In healthcare, AI might analyze medical scans while doctors focus on patient care. In education, AI could handle grading while teachers mentor students. The future isn't about humans versus machines. It's about finding the best ways to combine our respective strengths. Chapter 5. Meet the robots. When AI gets a body. The moment when artificial intelligence gains a physical form is when the magic truly becomes visible. Robots represent AI we can see, touch, and sometimes even hug, machines that don't just think but act in our physical world. From the Roomba vacuum cleaning your floors to the Mars rover exploring alien landscapes, robots are AI's hands, eyes, and legs extending into reality. Robots come in astonishing variety. Industrial robot arms in car factories can weld metal with millimeter precision, working tirelessly 24/7. Service robots like Pepper can read human emotions and carry conversations in shopping malls. Medical robots perform delicate surgeries with steadier hands than any human surgeon. Then there are swarm robots, tiny machines that work together like insect colonies, and humanoid robots like Boston Dynamics Atlas that can perform parkour moves. Each represents different ways AI interacts with our world. What makes a robot different from regular machines? 3 key elements. Sensors to perceive their environment, processors to make decisions, that's the AI brain, and actuators to physically interact with the world. Your microwave is just a machine, it doesn't adapt to its environment. But a robot vacuum uses sensors to map your home, AI to plan the most efficient cleaning path, and motors to navigate around obstacles. That's robotics in action. Let's explore how robots see the world, quite differently than humans do. While we rely on eyes, robots use combinations of technologies. LiDAR, laser radar, creates 3D maps by bouncing light pulses. Ultrasonic sensors work like bat echolocation, and computer vision algorithms process camera images. Some industrial robots even use tactile sensors, giving them a sense of touch more precise than human fingers. This multi-sensor approach helps robots understand surroundings in ways we can barely imagine. Robots are transforming workplaces in fascinating ways. In Amazon warehouses, thousands of wheeled robots swiftly move entire shelves of products to human workers, increasing efficiency while reducing injuries from heavy lifting. Construction robots can lay bricks or tie rebar with superhuman endurance. Agricultural robots like LettuceBot use machine vision to identify and precisely spray weeds, reducing herbicide use by 90%. These aren't job stealers. They're tools that handle dangerous, dirty, or repetitive tasks so humans can focus on skilled work. The medical robotics revolution is saving lives daily. The Da Vinci surgical system allows surgeons to operate through tiny incisions with magnified 3D vision and wrist instruments that bend like human hands, but without any tremor. Exoskeleton robots help paralyzed patients walk again. Tiny nanorobots may soon deliver drugs precisely to cancer cells. Pharmacy robots fill prescriptions with perfect accuracy, while disinfection robots roam hospitals zapping germs with UV light, especially crucial during pandemics. Home robots have evolved far beyond just vacuuming. Lawn mowing robots now handle yard work, window cleaning robots scale high-rises, and pool cleaning robots scrub surfaces automatically. Companion robots like LEQ assist elderly users with reminders and video calls. Even toy robots like Anki's Cosmo display shockingly lifelike personalities through advanced AI. The home helper robots of science fiction are gradually becoming reality, just less glamorous and more practical than movies predicted. Emergency response showcases robots' heroic potential. After the Fukushima nuclear disaster, specially designed robots explored radiation-filled areas too deadly for humans. Search and rescue robots can crawl through earthquake rubble using thermal imaging to locate survivors. Firefighting robots like the Thermite can enter blazing buildings when temperatures would kill human firefighters. Drones, flying robots, deliver medical supplies to remote areas and help fight wildfires with precision water drops. But building physical robots presents unique challenges. While AI software can be updated instantly, robots must deal with physics, gravity, friction, and unexpected real-world chaos. That's why robot development often moves slower than pure AI progress. The Moravec paradox observes that while AI excels at abstract tasks like calculus, it struggles with sensor-motor skills that humans master as toddlers, like picking up a cup without spilling. This explains why we have AI that can beat chess grandmasters but still lack robots that can reliably fold laundry. The future of robotics holds breathtaking possibilities. Soft robotics takes inspiration from octopus tentacles to create flexible, adaptable machines. Swarm robotics could enable thousands of tiny robots to self-assemble into different tools as needed. Advances in material science may lead to robots that can self-heal minor damage like living organisms. And brain-computer interfaces might one day let us control robots with our thoughts, already happening in early medical applications for paralyzed patients. As robots become more capable, important ethical questions arise. How do we ensure they make moral decisions in emergencies? Should lethal autonomous weapons be allowed? How do we prevent job displacement while benefiting from robotic labor? These aren't technical questions but human ones, reminding us that robots are tools we must guide wisely. The line between humans and robots may blur in surprising ways. Prosthetic limbs are becoming bionic with AI-powered control. Some researchers are developing cyborg cells that blend biological and artificial components. While true robotic consciousness remains science fiction, the integration of AI and robotics will continue transforming what machines can do in our physical world. Chapter 6. The Double-Edged Sword, AI's Bright and Dark Sides. The story of artificial intelligence isn't a simple tale of heroic technology or dystopian disaster. It's both simultaneously. Like fire, electricity, or nuclear power, AI is a transformative force that can warm homes or burn forests, depending entirely on how humanity chooses to wield it. This chapter confronts the uncomfortable truth that every breakthrough carries potential consequences, and that building a future where AI benefits everyone requires clear-eyed understanding of both its promises and perils. On the positive edge of the sword, AI is curing diseases that have plagued humanity for generations. DeepMind's AlphaFold has revolutionized biology by predicting protein structures with astonishing accuracy, a crucial step in developing new medicines. AI systems can now detect early signs of diabetic eye disease, lung cancer, and heart conditions from medical scans, often spotting what human doctors might miss. During the COVID-19 pandemic, AI helped researchers analyze virus mutations and predict infection hotspots, saving countless lives. These aren't incremental improvements but quantum leaps in healthcare capability. The environmental applications shine equally bright. Smart grids use AI to balance renewable energy sources, reducing fossil fuel dependence. Conservationists employ AI-powered camera traps to monitor endangered species and catch poachers. Startups are developing AI that analyzes satellite imagery to track deforestation, illegal fishing, and even methane leaks from space. Microsoft's AI for Earth program has supported over 500 projects fighting climate change, from optimizing irrigation in drought-stricken regions to protecting coral reefs through machine learning analysis of underwater sounds. Yet the other edge of the blade cuts deep. The same facial recognition that helps find missing persons also enables oppressive surveillance. In China's Xinjiang province, authorities combine AI with thousands of cameras to track minority populations relentlessly. Predictive policing algorithms in some cities disproportionately target black neighborhoods, perpetuating systemic bias under a veneer of technological objectivity. Even in democracies, governments increasingly use AI tools to monitor citizens' online activity, chilling free expression under the banner of national security. The workplace transformation presents another paradox. While AI eliminates dangerous jobs, like mining inspections now done by drones, it also disrupts livelihoods. Cashiers, truck drivers, and even radiologists face uncertain futures as automation advances. The World Economic Forum predicts AI will displace 85 million jobs by 2025 while creating 97 million new ones. But the transition won't be painless. Workers without digital skills risk being left behind, potentially worsening economic inequality. This isn't theoretical. Amazon's warehouse robots increased productivity, but also injury rates as human workers struggled to keep pace with machine-driven quotas. Perhaps the most insidious danger lies in AI's hidden biases. When a hiring algorithm favored male candidates, it wasn't because the AI was sexist. It had learned from historical hiring data that reflected human prejudices. Similarly, speech recognition systems often fail to understand accented or dialectal English, while image generators tend to default to white, Western representations unless specifically prompted otherwise. These aren't malfunctions but mirrors, reflecting society's flaws back at us through mathematical systems. The bitter irony? AI intended to eliminate human bias often ends up automating and scaling it. The weaponization of AI keeps military analysts awake at night. Autonomous drones can already identify and attack targets without human intervention. Cyber warfare tools powered by AI probe defenses and launch attacks at machine speed. Even more disturbingly, AI-generated deepfake videos could fabricate convincing footage of world leaders declaring wars or politicians confessing to crimes, potentially destabilizing entire nations. The Pentagon's former AI advisor recently warned that whichever nation leads in AI dominance will control the future of warfare, a terrifying prospect when combined with authoritarian regimes. On a personal level, AI threatens privacy in ways most people don't realize. The apps on your phone likely use AI to analyze your behavior, location, and even facial expressions to build psychological profiles sold to advertisers. Some schools have deployed AI that monitors students' webcams during tests, analyzing eye movements and facial micro-expressions for signs of cheating. Emotion recognition AI, though scientifically dubious, gets used in job interviews and border crossings, claiming to detect lies or attitudes from facial analysis. This constant surveillance chills free thought and behavior, the very essence of human dignity. Yet, for all these dangers, the solution isn't rejection but responsible development. The EU's proposed AI Act classifies systems by risk level, banning unacceptable uses, like social scoring, while strictly regulating high-risk applications. Tech workers at companies like Google have successfully protested against unethical AI projects, proving employee activism can steer corporate decisions. Researchers are developing constitutional AI that aligns with ethical frameworks, and explainable AI that shows its reasoning, crucial for building trust. The path forward requires vigilance from everyone. Citizens must demand AI transparency laws. Engineers need to build bias testing into development cycles. Policymakers should fund retraining programs for displaced workers. And all technology users, meaning nearly everyone, should understand enough about AI to question its applications rather than blindly accept them. This balanced perspective prepares us for Chapter 7's exploration of AI's most inspiring applications, how doctors, scientists, and social innovators are harnessing this technology to solve humanity's greatest challenges, from disease to hunger to educational inequality. The same double-edged sword that demands caution also offers unprecedented tools for building a better world. Chapter 7. AI as a superhero, how artificial intelligence is saving lives and solving global problems. Beneath the headlines about job losses and robot takeovers lies an inspiring truth. AI is quietly working to solve some of humanity's greatest challenges. Like a digital superhero team, researchers worldwide are deploying artificial intelligence to fight disease, feed the hungry, protect our planet, and educate the next generation. This chapter shines a light on these unsung victories, not to ignore AI's risks, but to show how we're harnessing its power for extraordinary good. In hospitals around the world, AI is becoming medicine's most powerful diagnostic partner. At Seoul National University Hospital, an AI system called Vuno detects breast cancer in mammograms with 97% accuracy, matching teams of expert radiologists. Meanwhile, Stanford's AI dermatologist can identify skin cancer from smartphone photos as reliably as board-certified dermatologists, bringing specialist-level care to remote villages. Perhaps most remarkably, Google's DeepMind created an AI that predicts acute kidney injury up to 48 hours before it happens, giving doctors crucial time to intervene. These aren't incremental improvements. They're revolutions that will redefine healthcare. The fight against infectious diseases has gained an AI-powered ally. During the COVID-19 pandemic, Blue Dot's algorithm spotted the outbreak days before official announcements by analyzing airline ticketing data and animal disease reports. Now, researchers are training AI to predict future pandemics by monitoring everything from climate change patterns to bat migration. In Africa, AI helps track malaria outbreaks by analyzing satellite imagery of standing water, mosquito breeding grounds, combined with local case reports, allowing targeted mosquito net distribution that saved an estimated 750,000 lives since 2015. Hunger and agriculture are being transformed by intelligent machines. In India, the startup Cropin uses AI to analyze satellite data and soil sensors, helping small farmers increase yields by 30% while using less water. Microsoft's FarmBeats project equips farms with low-cost sensors and AI analysis to fight crop diseases early. Even bee populations are getting AI assistance. The World Bee Project uses hive sensors and machine learning to monitor pollinator health globally, crucial for the 75% of food crops that depend on pollination. These technologies could help feed Earth's 10 billion people by 2050 without further deforestation. Education, the great equalizer, is being supercharged by AI tutors that never tire. In rural Kenya, students using the literacy app Mshule, which adapts lessons to each child's level via AI, improved test scores by 27% in months. Duolingo's AI language tutor now provides personalized practice with eerily accurate corrections, while Carnegie Learning's math software adjusts problems in real time based on student struggles. Most movingly, apps like Happy to Learn bring quality education to refugee camps, using AI to translate lessons into children's native languages and adjust to interrupted schooling, proving technology can be a powerful force for equity. Disaster response has entered a new era thanks to AI's rapid analysis capabilities. When Hurricane Harvey flooded Houston in 2017, an AI system analyzed thousands of social media posts to create real-time rescue maps, directing emergency crews to stranded victims faster than traditional 911 systems. In Nepal, drones with AI image recognition survey earthquake damage within hours, guiding rebuilding efforts. Even tsunami prediction has improved. Japanese researchers' AI analyzes ocean sensor data to provide earlier warnings, potentially saving thousands in vulnerable coastal communities. Environmental protection has found an unlikely champion in machine learning. Rainforest Connection attaches recycled smartphones to trees as guardian devices. Their AI listens for chainsaws and alerts rangers to illegal logging within minutes. Ocean Cleanup's AI identifies plastic pollution patterns across millions of satellite images, guiding cleanup ships to the densest patches. Perhaps most innovatively, Cornell's Bioacoustics AI analyzes animal sounds to monitor ecosystem health, hearing imbalances humans might miss until it's too late. These digital guardians work 24/7 to protect our planet's fragile balance. For people with disabilities, AI is dismantling barriers in astonishing ways. Seeing AI, developed by a blind Microsoft engineer, narrates the visual world through smartphone cameras, reading documents, describing scenes, even identifying currency. Google's Project Euphonia gives voice to those with speech impairments, translating unconventional vocal patterns into clear speech. Exoskeletons controlled by AI help paralyzed individuals walk again, while brain-computer interfaces let ALS patients communicate through thought alone. This isn't just technology, it's restoring fundamental human dignity. Scientific discovery is accelerating at unprecedented speeds thanks to AI lab partners. At MIT, An AI system called Eve discovered that a toothpaste ingredient could fight malaria parasites, a finding humans might have taken decades to uncover. DeepMind's AlphaFold has predicted structures for nearly all known proteins, 200 million, giving researchers the equivalent of a protein Google to develop new medicines. In Switzerland, AI sifts through particle collider data to spot potential physics breakthroughs among billions of collisions. These digital collaborators are expanding human knowledge at warp speed. The common thread? These aren't distant futures, they're happening now, often through collaborations between tech companies, nonprofits, and local communities. A teenager in Nairobi benefits from the same AI diagnostic tools as a grandmother in Tokyo. A farmer in Iowa uses similar precision agriculture tech as one in rural India. This global scale demonstrates AI's unique power to address both widespread challenges and deeply personal struggles simultaneously. Yet these superhero stories come with caveats. Even beneficial AI requires careful implementation. New agricultural tech must remain affordable for small farmers. Medical AI needs rigorous testing, and educational tools should complement, not replace, human teachers. The next chapter will explore how we can all participate in shaping this future, ensuring AI's benefits reach everyone equitably. Because the most inspiring AI applications share one trait: they amplify our humanity rather than replace it. Chapter 8. Can machines be creative? AI as artist, writer, and inventor. The canvas flickers to life as swirling colors coalesce into a breathtaking sunset over a cyberpunk cityscape, created entirely by an AI that's never held a paintbrush or felt awe at nature's beauty. In a London recording studio, a haunting melody composed by artificial intelligence is performed by human musicians, its harmonies somehow capturing emotional depths we assumed were uniquely human territory. This isn't science fiction. It's today's reality, forcing us to ask profound questions. Can machines truly create? Does originality require consciousness? And what does AI-generated art reveal about our own creative process? The creative AI revolution began subtly. Spotify's algorithm suggesting songs you might like, or your phone automatically enhancing vacation photos. But today's generative AI tools like DALL-E, Midjourney, and Stable Diffusion produce original images from text prompts that rival professional concept art. ChatGPT crafts poems, screenplays, and even novels that sometimes fool literary judges. Google's Music LM composes coherent musical pieces spanning genres from Baroque to K-pop, while tools like Jukebox can mimic famous singers' voices with eerie accuracy. These aren't parlor tricks. They're producing work that elicits genuine emotional responses from human audiences. How does AI creativity actually work? Unlike humans who draw from life experiences and emotions, these systems learn patterns from massive datasets. Every Renaissance painting, every Billboard hit song, every Pulitzer-winning novel. When you ask for a sad robot in Van Gogh's style, the AI doesn't contemplate melancholy or understand post-impressionism. It mathematically reconstructs patterns from thousands of sad images and Van Gogh paintings it's analyzed. The results feel creative because they combine elements in novel ways, but the machine experiences no inspiration, no creative struggle, no satisfaction in its art. This leads to fascinating collaborations between human and machine creativity. Professional artists now use AI as a brainstorming partner, generating hundreds of concept variations in minutes to spark new ideas. Architects employ tools like Midjourney to visualize building designs before drafting blueprints. Advertising agencies use AI to rapidly prototype ad campaigns, testing thousands of tagline and image combinations. Even Hollywood is experimenting. The 2022 short film, The Crow, featured AI-generated storyboards and script suggestions. Though every creative decision remained human, the literary world is equally transformed. When author Jennifer Lepp used AI to co-write her paranormal romance series, she described the process as having an infinitely patient writing partner who never gets tired of my ridiculous plot changes. The AI suggested character quirks and dialogue options, but Lepp controlled the narrative's heart and soul. Meanwhile, The Guardian published an op-ed entirely written by GPT-3 with human editing, demonstrating how AI could amplify marginalized voices by helping non-native speakers articulate complex thoughts. Music production has entered uncharted territory. Grammy-winning producer Alex da Kid now uses AI that analyzes hit songs to suggest chord progressions and instrumentation, not to copy, but to break my usual patterns. Startups like Boomi let anyone generate original music tracks in seconds, democratizing composition while raising questions about artistic ownership. Most remarkably, researchers have reconstructed Beethoven's unfinished 10th Symphony using AI that studied his complete works, allowing us to hear what the maestro might have created 200 years after his death. But AI creativity has serious limitations. These systems often struggle with true originality. Most outputs are sophisticated remixes of their training data. Without human lived experience, AI-generated art can feel technically impressive but emotionally hollow. There's also the plagiarism problem. When an AI-generated image wins a state fair art competition, as happened in Colorado 2022, does it violate the spirit of human creativity? Major legal battles are unfolding over whether AI can hold copyrights, and whether training models on copyrighted human works constitutes fair use. The philosophical implications run deep. If a machine produces work that moves us to tears, does its lack of consciousness matter? When an AI system invented a completely new toothbrush design, with optimized bristle patterns that outperformed human designs in clinical trials, did that count as innovation? These questions challenge our deepest assumptions about what creativity means, perhaps revealing that what we call inspiration has always involved recombining existing ideas in new ways, whether by neurons or algorithms. Educational applications show promise and pitfalls. Students in Brazil are using AI to overcome writer's block, generating essay outlines they then refine with critical thinking. But teachers worldwide report a surge in AI-generated homework submissions, forcing schools to reconsider assessment methods. This tension highlights a crucial point. AI works best as a creative catalyst rather than replacement, a tool that can help overcome blank page paralysis but can't replicate the intellectual growth that comes from genuine creative struggle. Looking ahead, the most exciting developments may be hybrid creations combining human and machine strengths. Imagine AI handling technical execution while humans focus on emotional depth, like a filmmaker using AI to generate background scenery while crafting the story's human elements. Or consider therapeutic applications already emerging. Art therapy apps that help trauma survivors express feelings through AI-assisted drawing, or music programs that translate brainwave patterns into melodies for nonverbal patients. As we stand at this creative crossroads, one truth becomes clear: AI isn't making human creativity obsolete. It's redefining what's possible when we partner with machines. The brush hasn't replaced the painter, but it's becoming smarter. In Chapter 9, we'll roll up our sleeves to explore how you can harness these tools yourself. No coding required, to become part of this creative revolution. Chapter 9. Hands-on AI, your first project. No coding needed. The screen glows as you type a simple command. Create a story about a robot who learns to love gardening. Seconds later, paragraphs appear. A tale complete with unexpected plot twists and vivid descriptions. You've just experienced the magic of creating with AI firsthand. This chapter is your practical toolkit, proving that you don't need to be a programmer or tech genius to start shaping artificial intelligence. Whether you're 10 or 40, these hands-on projects will transform you from AI spectator to active participant. Let's begin with something everyone uses daily: smart replies. Open your Gmail and compose a new message. Notice how Google suggests 3 response options like, "Got it? Thanks," or "I'll check and get back to you." Click one and watch it autocomplete into a full sentence. Congratulations, you've just collaborated with AI. This simple interaction reveals the core principle. AI works best as your assistant, not replacement. Try this exercise. For one day, use only smart replies, but then edit each one to sound more like you. Notice how the AI learns your style over time. Now let's generate some art. Head to a free tool like Night Cafe or Crayon. Type a description of anything you imagine: a cat astronaut planting flowers on Mars, or a waterfall made of liquid gold. Within minutes, you'll have original artwork. But here's the creative challenge. Use the first output as inspiration, then refine your prompt to get closer to your vision. For example, if the cat looks too cartoonish, add hyper-realistic 8K photography style to your next attempt. This iterative process mirrors how professional AI artists work. Each prompt is like giving the AI clearer instructions. Want to co-write a story? Open ChatGPT or Claude and try this. Let's write a fantasy story together about Your idea. I'll provide plot points and you help expand them. The AI will generate paragraphs based on your guidance. The key is staying in the director's chair. Make specific requests like, make the dialogue more dramatic, or add a plot twist where the hero fails. Save your favorite version, then edit it with your unique voice. Many young writers use this method to overcome writer's block, while professionals use it to brainstorm plot alternatives. Music creation has never been more accessible. Try SoundRaw.io or Boomi platforms where you select a genre, like upbeat pop or cinematic trailer. Set a mood, hopeful, mysterious, and generate original royalty-free tracks. For a fun challenge, create 3 different versions of the same song concept, then mix and match sections to build your perfect arrangement. Some classrooms use this to teach music theory. Students analyze how changing parameters like tempo or instrumentation alters the emotional impact. Now let's build a simple chatbot, no engineering degree required. Google's Teachable Machine lets you create an AI that responds to custom triggers. For example, 1. Train it to recognize pictures of your pets. Show 20+ photos of your cat/dog. Program responses. That's Mittens. She loves tuna. Or, this is Rover. His favorite toy is a red ball. Test it with new photos within minutes. You've created an AI that can identify and describe your animals. This same technology powers everything from museum exhibit guides to plant identification apps. For spreadsheet users, try AI-powered tools like ChatGPT for Sheets. Ask it to analyze these survey responses and identify 3 common themes. Or, create a budget plan based on my income and expenses. The AI acts like a supercharged assistant, handling tedious data work so you can focus on decisions. Teachers use this to quickly analyze student feedback, while small business owners track sales trends. Your most practical project? Supercharge your learning. Next time you're studying, 1. Ask an AI to explain photosynthesis like I'm 10. Request 5 real-world examples of geometry in architecture. Say, quiz me on the water cycle with 3 questions. This personalized tutoring approach helps visual, auditory, and kinesthetic learners alike. One high schooler used AI this way to go from failing to acing biology, not by having the AI do her homework, but by creating custom study aids that matched how her brain learned best. These projects reveal an important truth. AI literacy isn't about coding. It's about learning to collaborate with intelligent tools. Like any partnership, it works best when you 1. Start with clear intentions. Provide quality inputs. Guide iterations. Add your human touch. As we'll explore in Chapter 10, this human-AI collaboration is reshaping entire industries, and your future career will likely involve some version of these same skills at professional scale. Chapter 10. The future of work, how AI will change your career, no matter your age. Picture a typical workday in 2030. At an architecture firm, AI instantly generates 50 building designs meeting all safety codes and client preferences. But the human architect chooses the one that feels right and adds artistic flourishes. Across town, a nurse practitioner uses AI to analyze a patient's symptoms while she focuses on bedside manner and treatment explanations. Meanwhile, a 22-year-old social media manager trains AI tools to handle routine posts so she can develop deeper community engagement strategies. This isn't science fiction. It's the emerging reality of the AI-augmented workplace that awaits students, professionals, and career changers alike. The job market is undergoing its biggest transformation since the Industrial Revolution. A 2023 Goldman Sachs study estimates 300 million jobs worldwide could be affected by AI, not necessarily eliminated, but fundamentally redesigned. White-collar roles involving repetitive information processing, data entry, basic accounting, routine legal research face the most automation risk. Conversely, jobs requiring emotional intelligence, complex problem-solving, and creativity will become more valuable than ever. The key insight: AI won't replace most jobs, but people using AI will replace those who don't. Healthcare provides a clear example of this shift. Radiologists once spent hours analyzing scans. Now AI handles initial screenings, allowing doctors to focus on patient consultations and tricky edge cases. The profession hasn't disappeared. It's evolved. Similarly, accountants now oversee AI that crunches numbers while they provide strategic financial advice. Even creative fields see this pattern. Marketers use AI for data analysis and content generation, freeing them for big-picture campaign strategy. The common thread: AI handles predictable tasks, while humans manage nuance, ethics, and emotional connections. Emerging careers no one could have imagined a decade ago are now viable paths. AI trainers, teaching language models industry-specific knowledge, like medical terminology for hospital AIs. Prompt engineers, crafting the perfect instructions to get optimal results from generative AI. Robot teaming coordinators, managing human-AI collaboration in warehouses and factories. Digital ethics officers, ensuring companies use AI responsibly. AI-assisted educators, designing personalized learning experiences powered by adaptive technology. The skills that will future-proof your career have little to do with memorization and everything to do with distinctly human capabilities. 1. Critical thinking, evaluating AI outputs for flaws or biases. Creativity, combining ideas in ways machines can't replicate. Emotional intelligence, building trust and reading subtle social cues. Adaptability, continuously learning new tools and workflows. Leadership, guiding teams through technological change. Consider how this plays out across generations. For students, 10 to 18 years, your future jobs likely don't exist yet. Focus on learning how to learn skills through projects like coding a simple game, even if AI helps, or starting a YouTube channel using AI editing tools. These experiences teach tool adaptability more than any textbook. For young professionals, 18 to 30 years, you'll likely change careers 3 to 5 times. Treat AI tools like career Swiss Army knives, master prompt engineering across ChatGPT, Claude, and Gemini, then learn to automate parts of your workflow. A marketing associate using AI well could outperform senior colleagues stuck in old methods. For mid-career workers, 30 to 50 years, your experience is invaluable. When combined with AI, a teacher with 20 years experience plus AI tutoring tools becomes exponentially more effective. The key is reframing your expertise as what problems you solve, rather than what tasks you perform. The most exciting opportunities lie at the human-AI frontier. Healthcare AI diagnostics plus human compassion equals better patient outcomes. Law AI document review plus human judgment equals more accessible justice. Agriculture AI crop monitoring plus farmers' intuition equals sustainable yields. Creative arts AI production tools plus human vision equals unprecedented storytelling. Practical steps to prepare today. 1. Audit your job. List tasks by easily automated to requires human touch. Upskill monthly. Spend 2 hours per week learning AI tools in your field. Build an AI portfolio. Showcase projects where you directed AI assistants. Develop your human edge. Take improv classes for spontaneity or philosophy courses for ethics. The workplace of tomorrow values T-shaped professionals. Deep expertise in one area, the vertical bar, combined with broad AI collaboration skills, the horizontal bar. A graphic designer who understands AI image generation plus psychology of visual perception will thrive, while one relying solely on technical skills may struggle. As we'll explore in Chapter 11, this transformation extends beyond careers into how we'll continue learning throughout our lives. The era of 1 degree for life is ending, replaced by continuous human-AI co-learning, and those who embrace this fluidity will find extraordinary opportunities in the AI age. Chapter 11. Learning for Life, How AI is Transforming Education at Every Age. The classroom walls dissolve as 12-year-old Maria puts on her AR headset and is suddenly standing inside a beating human heart, her AI tutor adjusting the lesson in real time as it detects her confusion about the ventricles. Across town, 45-year-old construction worker David practices conversational Spanish with his AI language partner during lunch break, preparing for his company's expansion into Latin America. Meanwhile, 78-year-old retired librarian Margaret uses an AI memory coach to stay sharp, playing customized brain games that adapt to her cognitive patterns. This is the new lifelong learning landscape, where artificial intelligence doesn't replace teachers, but creates possibilities for personalized education at every stage of human development. Traditional education's one-size-fits-all model is crumbling under the weight of 2 realizations. First, that humans learn in radically different ways, and second, that career-changing skills must now be acquired throughout our lives. AI is emerging as the ultimate educational equalizer, not by standardizing learning, but by doing precisely the opposite. Adaptive learning platforms like Carnegie Learning's Mathia or Duolingo's AI tutors demonstrate what's possible, systems that track 87 data points per student, from time spent on problems to subtle hesitation patterns, to customized lessons with superhuman patience. The results speak for themselves. Students using these tools show learning gains 30 to 50% higher than conventional methods. Language acquisition showcases AI's transformative potential most dramatically. Tools like Elsa Speak analyze pronunciation down to the millisecond, giving feedback on specific vowel sounds in a way even the most attentive human teacher couldn't replicate. What's revolutionary isn't the technology itself, but its accessibility. A child in rural India now has a better pronunciation coach than the children of diplomats had 20 years ago. Research shows AI language learners acquire conversational skills 40% faster than traditional methods, with the AI's infinite patience eliminating the fear of embarrassment that stymies many students. For higher education and career training, AI is dismantling barriers to entry. Georgia Tech's Jill Watson, an AI teaching assistant that handled 10,000+ student questions in a master's program, proved that quality education can scale exponentially. Now, platforms like Coursera use AI to provide 1:1 writing feedback at scale, while medical schools employ virtual patient simulations that adapt to students' diagnostic choices. The most exciting development may be credentialing based on demonstrated competency rather than seat time, AI-powered assessments that verify real skills for employers, making degrees less important than actual capabilities. Adult learners face different challenges that AI is uniquely suited to address. Take vocational retraining. McDonald's UK uses an AI system that identifies transferable skills when workers want to move into healthcare or IT, then builds personalized upskilling paths. For time-strapped professionals, microlearning apps like Axonify deliver 3-minute daily lessons that compound into certifications, with AI optimizing content based on job performance data. The results are striking. Deloitte found organizations using AI learning platforms see 45% higher employee retention, as workers feel invested in rather than obsolete. Seniors represent perhaps the most overlooked beneficiaries of AI education. Startups like MemoryWell combine cognitive neuroscience with machine learning to create brain training that actually works. Not just crossword puzzles, but activities scientifically shown to strengthen neural pathways. Social robots like LEQ reduce isolation by facilitating video calls with family, while subtly encouraging physical activity and medication adherence. Most powerfully, AI voice assistants adapted for older users, with slower speech recognition and memory prompts, are helping dementia patients maintain independence longer than previously thought possible. The dark side of this revolution can't be ignored. There's real danger of over-reliance on AI tutors depriving children of crucial human mentorship. No algorithm can replicate the teacher who stays after class to nurture a student's passion for poetry. Privacy concerns loom large, especially when educational AI mines sensitive data about learning disabilities or attention spans. And the digital divide threatens to worsen unless access to these tools becomes truly equitable. A child without home internet is now at a far greater disadvantage than in the pre-AI era. The most effective implementations blend AI efficiency with human wisdom. Consider the human-AI loop model emerging in progressive schools. 1. AI handles skill drills and immediate feedback, math problems, language practice. Teachers review AI-collected analytics to identify class-wide trends. Human-led discussions tackle higher-order thinking and social-emotional learning. AI then extends these discussions with personalized follow-up questions. Parents can foster healthy AI learning habits right now. Use Khan Academy's AI tutor for homework help, but discuss the concepts afterward. Try creative apps like AI Dungeon for storytelling, then act out the stories together. Balance screen time with unplugged discussions about what the AI taught. As we'll explore in Chapter 12, this educational transformation ties directly to AI's role in addressing society's greatest challenges, because a population empowered to learn continuously throughout life becomes our most valuable resource in an age of rapid change. Chapter 12, AI for Good. Solving humanity's greatest challenges. A team of researchers in Nairobi stares at their laptop screens as an AI model processes thousands of satellite images, identifying villages at highest risk of famine so aid can arrive before children go hungry. Across the globe, marine biologists deploy AI-powered underwater robots that listen for illegal fishing activity across millions of square miles of protected ocean. These aren't hypothetical scenarios. They're happening right now. demonstrating how artificial intelligence is emerging as one of our most powerful tools for tackling problems that have plagued humanity for generations. The scale of AI's potential for social impact becomes clear when we examine global health initiatives. In rural India, where doctor shortages leave millions without basic care, Armin's AI system analyzes pregnant women's risk factors from simple SMS check-ins, reducing maternal complications by 30%. For tuberculosis detection, a disease that still kills 1.5 million annually, AI now analyzes cough sounds recorded on basic smartphones with 85% accuracy, bringing diagnostics to remote areas. Perhaps most remarkably, Google's AI can now predict floods up to 7 days in advance across 80 countries, using disparate data sources traditional models couldn't synthesize, giving vulnerable communities unprecedented warning to evacuate or prepare. Environmental conservation efforts are being supercharged by intelligent algorithms. The nonprofit Rainforest Connection attaches old smartphones to trees as guardian devices. Their AI listens for chainsaws up to 3 kilometers away and alerts rangers to illegal logging in real time. In Africa, PAWS, Protection Assistant for Wildlife Security, uses game theory algorithms to predict poacher movements, helping park rangers patrol more effectively, resulting in 5x more intercepted poaching attempts. Even coral reefs are benefiting. Researchers deploy AI that analyzes thousands of underwater recordings to monitor ecosystem health through fish vocalizations and invertebrate sounds, detecting environmental stress humans would miss until visible damage occurs. Disaster response has entered a new era through AI's rapid pattern recognition. When Hurricane Maria devastated Puerto Rico in 2017, researchers at Carnegie Mellon developed an AI that analyzed social media images to map damage faster than FEMA's traditional assessments. Now, the UN's Global Pulse Initiative uses AI to track 300+ data streams, from satellite imagery to refugee camp Wi-Fi usage, predicting food shortages before they become famines. During the 2023 Turkey earthquakes, AI sorted through thousands of survivor locator requests, prioritizing the most urgent cases and matching them with nearby rescue teams, saving crucial hours when minutes mattered. Education inequality, one of society's most persistent challenges, is being addressed through AI's ability to democratize quality instruction. In Brazilian favelas where schools often lack resources, the One Mio platform uses AI to adapt math and science lessons to each student's level, delivered through basic smartphones. For refugee children displaced by war, apps like Chatterbox provide AI-powered language tutoring combined with curriculum tailored to disrupted education histories. Most inspiring may be RoboBraille, an AI service that instantly converts textbooks into Braille, audio, or simplified formats, serving over 300,000 visually impaired or dyslexic students across Europe. Poverty alleviation strategies are becoming more targeted thanks to AI's analytical power. In Colombia, the government uses an AI system called Sire that analyzes 300+ variables, from nighttime satellite images of light distribution to mobile payment data, to identify households most likely to fall into extreme poverty, enabling preventative aid. Microfinance platforms like Tala employ alternative credit scoring through AI, evaluating applicants' digital footprints to extend loans to those without traditional banking histories, helping small business owners in Kenya, Mexico, and the Philippines bypass predatory lenders. Scientific research is accelerating at unprecedented speeds through AI collaboration. At MIT, an AI model called Graph Networks analyzed millions of chemical combinations and identified a new antibiotic halicin that kills drug-resistant bacteria, a discovery that might have taken humans decades. Climate scientists now use AI to run ultra-detailed climate models, processing petabytes of atmospheric data to predict regional effects with startling precision. Even particle physics benefits. At CERN, AI sifts through 1 billion proton collisions per second at the Large Hadron Collider, flagging the 100 or so daily events that might reveal new physics. The common thread across these applications is AI's ability to see patterns across scales, connecting microscopic data points to reveal macroscopic solutions. A health AI correlates local weather patterns with mosquito breeding rates to predict malaria outbreaks. An agricultural system cross-references soil sensor data with satellite imagery to advise farmers. These multidimensional analyses were previously impossible not because the data didn't exist, but because no human team could process such vast, interconnected information streams. However, these tools work best when guided by human wisdom. The most effective projects follow a human-in-the-loop model. AI identifies patterns and makes predictions. Flood risk areas. Local experts contextualize the findings, knowing which villages have elderly populations. Communities implement solutions, organizing evacuation routes. AI then measures intervention effectiveness for continuous improvement. This collaborative approach avoids the pitfalls of techno-solutionism, the naive belief that technology alone can fix complex human problems. An AI might perfectly identify which students are struggling academically, but only human mentors can address the underlying causes like housing insecurity or family trauma. Young readers can already contribute to this movement through citizen science projects. Classify wildlife images on Zooniverse to train conservation AI. Play Fold It, a game where human puzzle solving helps design new proteins. Report local environmental changes to apps like iNaturalist that feed into global models. As we'll see in Chapter 13, realizing AI's full potential for good requires addressing significant ethical challenges, because even the most well-intentioned technology can cause harm without proper safeguards. The same algorithms predicting disease outbreaks could be weaponized. The data empowering microfinance might enable exploitation. Navigating these dual possibilities wisely will determine whether AI becomes humanity's greatest ally or its most destabilizing force. Chapter 13. The Ethics of Intelligence, Navigating AI's Moral Maze. A courtroom in Wisconsin erupts in protest as a defendant learns his 6-year prison sentence was determined not by a judge, but by an algorithm that scored his future criminal risk. Meanwhile, a Nigerian father stares helplessly at his denied loan application, rejected by AI that deemed his neighborhood too high risk based on aggregated mobile payment data. These real-world scenarios reveal the thorny ethical landscape we've entered, where artificial intelligence doesn't just recommend songs or tag photos, but makes decisions that profoundly impact human lives. This chapter doesn't offer easy answers, but equips you to ask the right questions about fairness, accountability, and power in the age of machine intelligence. The fundamental ethical dilemma of AI stems from a paradox. We're creating systems that can make decisions faster and more accurately than humans, yet lack human judgment or accountability. Take Compass, the criminal risk assessment software used in courts. Investigations revealed the algorithm was twice as likely to falsely flag black defendants as high risk compared to white defendants. Not because its programmers were racist, but because it learned patterns from historical arrest data that reflected systemic biases. This phenomenon, where AI amplifies societal prejudices under the guise of mathematical objectivity, is what data scientists call the tyranny of the default. The algorithms inherit our world's inequalities unless deliberately designed otherwise. Privacy erosion represents another ethical fault line. The average urban resident is now captured by 300+ facial recognition cameras daily, while our smartphones transmit behavioral data to dozens of AI systems. In China's social credit system, this surveillance reaches dystopian levels. Citizens receive scores affected by everything from jaywalking to spreading negativity online, which then determines their access to loans, schools, and jobs. Even in democracies, schools have deployed AI that monitors students' webcams during tests, analyzes their keystroke patterns for cheating signals, and tracks emotional states through facial analysis, a field with shockingly little scientific validity. The question isn't just what AI can do, but what it should do in a free society. The labor disruption caused by AI automation raises urgent ethical questions too. When self-checkout kiosks replace cashiers, or AI legal tools displace paralegals, who bears responsibility for workforce transitions? The case of Amazon's algorithmic warehouse offers a cautionary tale. Workers reported being monitored so intensely by productivity tracking AI that they avoided bathroom breaks, leading to dangerous dehydration. Conversely, Denmark's technology pacts show an ethical alternative: unions, companies, and government collaborating to retrain workers before automation hits, ensuring no one gets left behind. The moral imperative is clear. Technological progress shouldn't come at the cost of human dignity. Perhaps the most unsettling ethical frontier is autonomous weapons. The EU reports that Turkish-made drone swarms with facial recognition AI have already hunted down human targets in Libya without final authorization from officers. The EU Department of Defense's Project Maven develops AI that can identify combatants in drone footage, raising nightmarish scenarios of machines making life-or-death decisions. Over 30 countries have called for a ban on lethal autonomous weapons through the Stop Killer Robots campaign, while others argue such bans are unenforceable. This debate strikes at humanity's core. Should we ever outsource the decision to take a life to algorithms? Children and AI interact in ethically complex ways too. Studies show teenagers form emotional attachments to AI chatbots like Replica, sharing intimate thoughts they wouldn't tell parents. But where does therapeutic support end and manipulation begin? Educational apps use addictive design perfected by TikTok's AI to maximize engagement, sometimes at the cost of deep learning. The most vulnerable pay the highest price. Investigators found AI-generated child sexual abuse images proliferating on the dark web, created by image generators trained on illegal material. These horrors remind us that every transformative technology carries a shadow side we must confront. The environmental cost of AI is often overlooked in ethical discussions. Training a single large language model like GPT-3 consumes enough electricity to power 120 homes for a year and emits as much carbon as 300 round-trip flights between New York and San Francisco. Bitcoin mining, heavily reliant on AI optimization, now uses more electricity annually than Argentina. As climate change accelerates, we must ask whether some AI applications justify their ecological damage and push for green AI, innovations like Google's use of deep learning to reduce data center cooling costs by 40%. Hope emerges from global efforts to build ethical guardrails. The EU's AI Act establishes a risk-based regulatory framework banning unacceptable uses, like social scoring, while requiring strict oversight for high-risk applications, like hiring algorithms. Tech worker movements have successfully halted unethical projects. Google employees forced cancellation of AI contracts with the Pentagon, while Microsoft workers protested facial recognition sales to ICE. Perhaps most promising are constitutional AI approaches where systems like Anthropic's Claude are trained on explicit ethical principles that constrain their behavior, similar to Asimov's 3 laws of robotics made real. Every technology user, meaning nearly all of us, has a role in shaping AI ethics. Practical steps you can take today. 1. Demand transparency. Ask schools or employers what AI systems they use and how decisions are made. Check your digital footprint. Use privacy tools like DuckDuckGo or ProtonMail to limit data harvesting. Support ethical AI. Choose services like Ecosia, AI-powered search that plants trees, over extractive alternatives. Stay informed. Follow organizations like the Algorithmic Justice League or AI Now Institute. The teenage activists fighting for ethical AI might inspire us most. When 17-year-old Sneha Ravaner discovered bias in her school's grading algorithm, she launched Encode Justice, now a global youth movement holding tech companies accountable. Similarly, 15-year-old Emma Yang developed an AI memory aid for Alzheimer's patients after seeing her grandmother's struggle. Proving ethical AI isn't just about restrictions, but positive innovation. As we'll explore in our final chapter, the ultimate question isn't whether AI will change society. It already has, but whether we can guide that change toward justice, equity, and human flourishing. The algorithms themselves have no moral compass. That responsibility remains irreducibly human. Chapter 14. The Future We Choose. Shaping the AI revolution together. The year is 2035. You wake to an AI assistant that knows you're stressed about an upcoming presentation and has already adjusted your schedule to include meditation time. Your child's AI tutor detected their growing interest in marine biology and arranged a virtual dive with oceanographers. At work, you collaborate with colleagues across 3 continents via real-time AI translation, while an ethics review board of humans and AI jointly approves your company's new algorithms for bias. This isn't a predetermined future. It's one possible outcome we're collectively choosing right now through the decisions we make about artificial intelligence. The most important truth about AI's trajectory is that it's not like weather, an uncontrollable force of nature, but like architecture, a constructed environment we deliberately design. Every line of code, every dataset selected, every policy enacted represents a brick in the edifice we're building. The choices being made today by programmers, legislators, teachers, and even teenagers will determine whether AI becomes humanity's greatest ally or most destabilizing force. This final chapter isn't about prediction, but empowerment. Concrete ways you can help shape an AI future that enhances rather than diminishes our humanity. Democratizing development is our first imperative. Currently, just 3 companies control over half the world's advanced AI capacity: while 90% of AI professors are men. This concentration risks building technologies that reflect narrow perspectives. But grassroots movements are changing this. The Masterclass project supports African natural language processing for indigenous languages. India's AI for All initiative trains women and rural communities in AI basics. Teenage coder Tanmay Bakshi created AI apps for disability support that corporations overlooked. These efforts prove AI development shouldn't be left solely to Silicon Valley elites. You don't need a PhD to contribute. Participating in open-source AI projects or even providing local data, like regional speech patterns to improve voice assistance, helps diversify these systems. Reimagining education forms our second pillar. Finland's groundbreaking 1% AI training program has taught over 1% of its population, 55,000 plus people, AI fundamentals, from nurses to truck drivers. Similar initiatives are emerging worldwide. Singapore's AI for Everyone free online course, Brazil's mandatory AI literacy in high schools, Toronto's AI mentorship pairings between tech workers and community groups. The goal isn't creating more programmers, but fostering AI bilingualism, the ability to converse between human needs and machine capabilities. A teacher understanding how AI grading works can advocate for better tools. A small business owner knowing AI basics can avoid exploitative tech contracts. Policy and governance represent our third crucial lever. While the EU leads with comprehensive AI regulation, local actions matter too. New York City now requires AI hiring tools to pass bias audits. Portland banned facial recognition in public spaces. Barcelona established a digital sovereignty initiative for ethical municipal AI. Citizens have more influence than they realize. When 100,000 parents petitioned against emotionally manipulative AI in children's apps, major platforms changed their algorithms. Your school board or city council likely has technology committees needing public input. The AI future gets built by those who show up. Human-centered design must guide all progress. Japan's Society 5.0 initiative exemplifies this, measuring success not by technological sophistication but by human outcomes. Robot caregivers designed to support, not replace, human nurses. Workplace AI that reduces overtime rather than increasing monitoring. This philosophy birthed innovations like the AI suitcase, a self-navigating mobility aid for the visually impaired that respects user dignity. Contrast this with productivity-maximizing warehouse AI that tracks workers' every movement. The difference isn't technical capability, but fundamental values. Your toolkit for shaping the AI future. 1. The three-question filter for new tech. Does this expand or restrict human agency? Who benefits and who bears the risks? How might this impact someone without my privileges? 2. Daily digital hygiene. Use privacy-preserving tools like Signal and Firefox. Regularly audit app permissions on your devices. Support ethical AI companies through your consumer choices. Community building. Start an AI book club discussing works like Atlas of AI. Volunteer to test local government AI systems for accessibility. Mentor someone in AI basics. Understanding breeds empowerment. The most inspiring developments happen at the grassroots. In Nairobi, residents used AI to analyze slum infrastructure needs, creating maps that forced government action. Alabama high schoolers built an AI that exposed racial bias in school disciplinary records. A Taiwanese collective developed civic AI tools that visualize policy impacts for voters. These examples prove you don't need corporate backing to steer AI toward justice. As we stand at this crossroads, remember, the Luddites weren't anti-technology. They were skilled weavers fighting for machines that enhanced rather than erased their craft. Our task is similarly nuanced. The AI revolution won't be stopped, but its course can be shaped toward compassion over control, empowerment over extraction, and collective flourishing over corporate profit. Epilogue: Becoming Good Ancestors in the Age of AI. As you close this book, your smartphone buzzes with a notification. The AI-powered weather app warning of an approaching storm it predicts will hit your neighborhood hardest. This simple moment encapsulates our central tension. We now live with technologies that feel simultaneously miraculous and mundane, powerful yet intimate. The story of AI isn't about toasters gaining consciousness or robot uprisings. It's about whether we can wield this tool wisely enough to deserve its gifts. The indigenous concept of seventh-generation thinking asks us to consider how our decisions will ripple 175 years into the future. As we plant the seeds of artificial intelligence today, what forests are we growing for our great-great-grandchildren? Will they inherit systems that amplify human dignity or erode it? Technologies that heal divisions or deepen them? This isn't rhetorical. The high school students reading this may well live to see 2100. The newborns in their families could witness 2120. 3 compasses for the road ahead. 1. The empathy imperative. Every AI system is ultimately a mirror. When we build facial recognition that struggles with dark skin, we see our societal blind spots. When chatbots reflect gender stereotypes, they reveal our unexamined biases. The most important algorithm we'll ever design is the one running in our own minds, the values we choose to prioritize. Ask constantly, who might this harm? As diligently as we ask, what can this do? 2. The participation principle. The AI future won't be shaped by those who understand it best, but by those who care enough to engage. You needn't become a data scientist to make a difference, just as you needn't be a mechanic to demand safe cars. Attend one city council meeting on smart city proposals. Test an educational AI tool and give feedback. Organize a community discussion using this book's guide. Democracy in the digital age requires showing up. The Long Now Mindset, Stanford's 100-year study on AI, reminds us that this technology will evolve across generations. The children building Lego robots today will retire in a world where AI is as ubiquitous as electricity. Teach them not just how to code, but how to question. What problem are we solving? Who benefits? What world does this create? Your invitation to history. Next month, researchers will publish another breakthrough. A corporation will deploy another controversial system. A policymaker will draft another regulation. But in a Mumbai slum, a grandmother is helping train an AI to recognize early signs of diabetic retinopathy in her community. In a Norwegian classroom, students are debating AI ethics through role-playing games. In a Detroit garage, a teen is building an assistive device for her wheelchair-bound neighbor. The most important developments in AI won't come from labs or boardrooms, but from millions of ordinary people insisting that technology serve human flourishing. That includes you reading these words. The next chapter of the story isn't in any book. It's in the choices you'll make tomorrow, next month, across your lifetime. When your grandchildren ask where you stood as the AI revolution unfolded, may you have stories worth telling. End of book. Postscript resources. For young readers, 10 to 15 AI Guardians comic series showing ethical dilemmas. Train your own AI pet. Beginner project kit list of student AI ethics competitions for adults and educators. AI literacy. Lesson plans for all ages, directory of responsible AI tools for schools / businesses, template for lobbying local representatives about AI policies for families. Future night discussion cards about tech scenarios, family pledge for balanced tech use, AI safety. Checklist for smart home devices.